Good morning. Chapter 13. This, in my opinion, is probably the hardest chapter in the book. So those of you who are in class are smart. Those of you online, I'll try to go slowly and try to help you guys out. Okay, but either way you look at it, put some time into trying to figure out what's going on here because it forms the basis for the rest of the chapters that we're doing. So after this we do 14, 15, 16, and 17. There's 4 more chapters after this one. And every single one of them relies on this guy. Okay? Okay, so in order to kind of help this chapter move along, because it is difficult, I want you to sit and I want you to think about costs. Okay? This whole chapter is about the costs of production. Again, as a reminder, when I say costs in this class, I don't mean like, oh, I went to the store and milk cost me $4. No. That we refer to as the purchase price. The price of milk was $4, right? When I say the cost of the milk, I mean how much did it cost the firm to produce the milk? Does that make sense? Okay, so I'm talking about the costs from the firm side, the factory side. So you have to put yourself, put the hat of you are a firm owner now, right? You're not a buyer right now, you're a seller. You're a supplier, okay? So imagine that you run Ford Motor Company, okay? Just think of some costs. They can be anything. You can just kind of yell them out. But I want you to think of a couple of costs, maybe 3 of them, and I want you to think about like some sort of decisions that you make that are determined by your costs. Okay, so what do we got? What do you think? Materials. Very good, right? You need tires and sheet metal and engines and all kinds of stuff, right? Very good. Workers. Labor costs. You definitely need laborers. Okay. Technology costs, right? Okay, these are very good. Any other costs? There's probably a lot of them, right? You have to pay for a factory. You have to pay for utilities and lights and that sort of thing. You might have to pay a big cost up front, like when you build a new factory, and then a small cost if you rent the factory or something like that. So, different business decisions, any ideas? So, the cost. Materials, it might make you decide whether to use more or less of them in a car, right? Labor. Well, if labor is expensive, should I switch more to those robots instead of the people? Right? Maybe if labor is expensive. Okay. Right? Factory prices. You might decide to build one big factory versus a couple of small factories or something like that. Right? Okay. All costs, and they all change my decision-making process. So what I want you to look for in this chapter are the answers to these questions. Okay. What's a production function? Right? I'm going to teach you this thing called production function. What is marginal product? And how is a production function and marginal product related together? Remember those words? These are very important words, by the way. What are the different types of costs that just a firm in general, that abstract firm has, and how are they related to each other? And then are costs different in the short run versus the long run? What are economies of scale? It's a new definition word I'm going to teach you today. Okay. So let's begin with some easy stuff. So total revenue, total cost, and profit. How do I relate those? Well, we're going to assume that every firm's goal is to maximize profit. That makes sense. We're okay with that assumption, right? Every firm just wants to make as much profit as possible. Well, what is profit? Profit is total revenue, the total amount that you get from the product, minus the total cost that it costs to make it. Right? Does that make sense? If I think back to a supply curve and a demand curve, and this is the price and the quantity. Remember, total revenue is the total number of dollars spent on the good, right? So if I sold Q goods and people bought them from me for P dollars, what's my total revenue? P times Q, which graphically I can just think of it as the area of this box right here, right? So that's total revenue, is P times Q. Okay, so again, total revenue, the amount a firm receives from the sale of its output. Okay, and the total cost is all of the inputs that it uses And then how do we value them? We value them in the market value, right? All right, so let's think about costs. There are costs can be divided into two main groups: explicit costs versus implicit costs. Everybody easily can think about explicit costs. The ones that people have problems with are these implicit costs, okay? So explicit costs are easy because you actually take money and you pay them to someone, right? So if you have to buy materials or if you have to buy laborers, you pay laborers a wage, you actually are writing them a check. There's a dollar value. It's easy to calculate explicit costs, okay? Implicit costs, though, are the difficult ones, but you still have to remember about them. It's the opportunity costs. Remember opportunity costs? A long time ago, right? If I own a factory and I'm working in the factory, I don't have to pay myself if it's my factory, right? But I have to remember that every hour that I'm there at the factory, I'm giving up an hour working someplace else. It's an opportunity cost, right? So even if I come to my factory, and even if I'm just managing, right, and I'm not drawing a salary, it's still a cost. I'm still costing the hours that I'm there because I could be working somewhere. I could be working somewhere else. Okay? So this implicit cost, everybody always forgets about. Okay? So don't forget that one of our big 10 principles, the cost of something is what you give up to get it. So in order to produce a good, what did we give up to produce the good? You have to think of everything, not just the money and the inputs and the laborers, but also the opportunity cost of people's time. All right? So whether the costs are implicit or explicit, they both matter for firms' decisions. Okay? Now, one of the main errors that people can make when they calculate, oh, how much does it cost to produce this good, is they just look at the actual dollars that were paid out. Okay? For example, I have a friend of mine who is a cupcake maker, right? And he's actually a baker, but he can make cupcakes. And so he was trying to figure out, well, if I'm going to sell these cupcakes to this big store, how much does it cost me to make them, right? So we went to Costco and we looked at flour and sugar and everything like that. And he added it all up and it was like $1.10 per cupcake, right? But that's not how much it really costs to make the cupcake. What was he forgetting? The value of all his time that he was going to spend making this cupcake, right? And so that's the implicit cost that everybody always forgets about. Okay? So here's an example. Let's say that you need $100,000 to start your business. There's an interest rate from the bank at 5%, meaning I could take a loan and I could get 5% and I owe 5% interest on it, or I could give a loan to someone and I would earn 5% interest on it. Okay? Now, scenario one. Let's say that you have to borrow $100,000. Okay? What's the cost of borrowing $100,000? This is kind of simple. The interest rate is 5%. You borrowed $100,000. What's the cost to you? What's the cost of a loan? 5% of $100,000, so it's $5,000 interest on the loan. Is that an explicit cost or an implicit cost? That's explicit, because at the end of the year, you literally have to write a check for $5,000 extra dollars back to this guy, to the bank. Does that make sense? It's an actual transfer of money. Now, are there any implicit costs? No, because you just borrowed the money. But let's say that you have $40,000 in savings, okay, and you only have to borrow $60,000. Well, should you do that? Is the cost going to be less? Right? So the idea here is many people are going to look at this and be like, oh, you should definitely do this because look, you're going to have to pay interest on $100,000 here, but if you do this, you're only going to have to pay interest on $60,000. The costs will be less, right? Well, let's think about it. What is the explicit cost at the end of the year for this scenario? The explicit cost. How much interest are you going to have to pay back to the guy? To the bank? $3,000, right? 5% interest on the loan, you're going to have to pay $3,000, right? But is there an implicit cost? You better believe it. Because you used that $40,000 and you put it into your factory, right? Along with the $60,000 from the bank, you got it all together. But you could have done something else with that $40,000. What could you have done? What could you have done if you had $40,000? I could have loaned it out to someone else. Does that make sense? And how much would I have made on it? 5% interest, right? So I would have made, what's 5% of $40,000? It's $2,000, right? So it's actually an implicit cost. The fact that I took that $40,000 and used it for my factory and I didn't loan it out to someone, I gave up $2,000 of interest that I could have earned. We'll call that foregone interest, right? That I could have earned on the $40,000. Does that make sense? So there still is a cost to using your own money, because you could have taken your own money and you could have paid, made a loan and gotten interest on it, right? So in both cases, the total costs are both $5,000. In both cases, the total costs are $5,000. That make sense? So really, these are both equally costly scenarios. If it costs $100,000 to start your business, whether you have to borrow all of it or none of it, it's still going to cost you whatever the interest rate is, right, in order to start your company. Okay, so this leads us to our next topic when we look at economic profit versus accounting profit. So accounting profit is what you're very familiar with. It's total revenue and you take off the explicit costs. Right? This is what your accountant can do if you're a factory owner, right? Your accountant at the end of the year, he takes the total amount of dollars that you had come in minus the total amount of dollars that you had come out, and he comes up with some number, accounting profit. Okay? But what's your accountant missing? He took total number of dollars that came in, subtracted off total number of dollars that came out. What is he missing? The implicit costs, right? He doesn't know to subtract the implicit costs, okay? So that is called economic profit. When I take total money that comes in minus all of my costs, both explicit and implicit, right? That's called accounting profit. Okay? So which of these numbers is always going to be bigger? Accounting profit, right? Because basically, accounting profit, you have revenue minus the explicit costs. Economic profit, you have revenue minus explicit and implicit costs, right? So you're subtracting more away from the economic profit. Does that make sense? You're subtracting more away. So this is always going to be smaller. This is always going to be bigger. And that's why, because it ignores the implicit costs. It's just forgetting about the implicit costs. Okay. All right. Let's do a practice of calculating economic profit versus accounting profit. So imagine that you're paying some quantity for your office space, and all of a sudden it goes up $500 per month. Okay, so you're not paying $500 a month; it's going up $500 a month. So to make it really easy, imagine you're paying 0 at the beginning, and now you're paying $500 a month for your office space. Okay, determine the effects on accounting profit and economic profit if you rent your office space or you own your office space. Okay, so what happens to my accounting profit and economic profit if I rent and if I own? Okay, I'll give you guys a couple seconds to think about that. And the way to do that is to do accounting profit is total revenue minus explicit costs, and economic profit is total revenue minus all the costs, explicit and implicit costs. Okay. So if it's helpful, you can kind of go, okay, in scenario A, before you can do accounting profit. By the way, I'm going to use the pi symbol for profit, because I can't use P, because P is already used for price, right? Okay, so calculate accounting profit and economic profit, and then do after accounting profit and economic profit. And then you can do the same thing for scenario B. That's basically what I'm asking. And then you're going to compare these two and compare these two. Okay, so let's imagine that you rent your office space. Okay, you rent your office space. So we're in scenario 1. Okay. What's going to happen if to your costs if the rent on office space increases $500 a month? Your costs will go up $500 a month, which means your profit goes down $500 a month. Okay? So your explicit costs increase $500 a month. That means that your accounting profit goes down $500 per month, and your economic profit go down $500 per month. Why? Because remember, accounting profit is just total revenue minus the explicit costs, and economic profit is total revenue minus total costs. So in both of these situations, these are both going up $500 a month. So your accounting profit is going down $500 a month. That make sense? Okay. Let's do scenario B, which is where you own your office space. Rents are going up. Do you care? No? Yes? This is the part. This is what I want you guys to think about, right? Because this is the tricky question. Do you care? Well, the accountant, does he care? No, because are your explicit costs going up? No. You own your own office space. The rents can do whatever they want, but you have zero explicit costs for rent, right? So accounting profit stays the same. It does not change, right? However, let's think like economists, not like accountants, because we're economists, we're not accountants, right? What cost are we forgetting about? The implicit cost, which means I own office space. If the rents go up, maybe more people are going to want to buy my office space. Maybe, because it's more expensive. But even more simple than that, if the rents go up, I could just move out of my office space, I own it, and I'll rent it to someone else, right? So the fact that I'm not renting it, I'm losing out on that $500 extra a month that I could be renting it out to someone else. Does that make sense? I'm losing out on an extra $500 a month. So that's going to be considered a cost. But is that an explicit cost? No, because I'm not actually paying someone the $500 a month. So it's called an implicit cost, all right? So explicit costs do not change, therefore accounting profit does not change, but the implicit costs go up by $500 a month because I'm losing out on that $500 a month if I stay in my office space. I could be getting extra $500 a month, so that still should be a cost, right? So the economic profit falls by $500 a month. And this is why it's important to think in terms of economic profit, not accounting profit. Okay? Economic profit, you see, in either situations, whether you rent or whether you own, it doesn't matter. Economic profit always goes down $500 a month, right? Accounting profit has this weird thing where it's going down here and it's not going down here, right? But how can that be? That doesn't make sense. I mean, we're asking for the cost of the output, the product, right? It shouldn't matter whether you own or rent one of your inputs, right? We want to know the cost of the output, and it should be the same regardless. That's why we have to use this idea of economic profit, because it takes care of all these problems, okay? So economic profit is the relevant cost in decision making for this class. That's what economists think about, right? It includes opportunity costs. Okay, let's now talk about the production function. So a production function, if you continue on economics, you'll hear this many, many times. It's just a formula that tells you how much output you get when you put in a certain amount of input. How much output you get when you put in a certain amount of input. Right? It's a production function. It's a function produces of production. Right? So you can imagine it's a mathematical function. In comes some inputs, out goes some outputs. That's the production function. Okay. So you can write it as a table, right? Inputs and outputs. You can write it as an equation, or you can write it as a graph. Okay? Like everything in this class, you could do the table or the graph or the equation. We'll mostly focus on graphs and tables in this class. We normally don't focus too much on equations. Okay, so let's do example 1. There's a guy, his name's Farmer Jack, and he grows one good in his wheat. Okay. Remember, all models in this class are as simple as possible, so there's one guy, there's one product. We could make this more difficult if we wanted to, but no need to. Right? As simple as possible. And he has 5 acres of land. He uses that as an input. And he can hire as many workers as he wants. Okay. And finally, the only thing that he needs to make the wheat is the land and the workers. Just make it as simple as possible, right? We have some capital, let's call it the land, is capital, and we have some labor, some workers. Okay, that's all we've got. All right, so let's write down the production function as a table. Now, when he has 0 workers, how much wheat does he make? 0. Okay, that's obvious. So then let's graph that. It's at 0, 0. Okay. Now here I'm going to start making up some numbers. When he has 1 worker, let's say he has 1,000. He can make 1,000 bushels of wheat with his 5 acres. Right. 1 worker he hires, 5 acres. The guy works and he produces 1,000. So then I go ahead and graph it here at 1, 1,000. Right. Let's say when he hires 2, it goes up to 1,800. Okay. 1,800. Right? So let's go 2, 1,800 here. Let's say that when he hires 3, it goes up to 2,400. So we got 3, 24. Let's say when he hires 4, it goes up to 2,800. Again, right there. And 5, it goes up to 3,000. Okay? And then we can go ahead and connect those with a line. And we get something that looks like that. Okay? So you see what's happening here? Basically, when he hires 1 worker, the 1 worker gets to roam on 5 acres of land and plant on 5 acres of land, right? But when he hires 2 workers, they each have to split his 5 acres. So they each only get 2.5 acres each, right? When it goes all the way up to here, when he has 5 workers, they each only get 1 acre to work on each, right? Pretty much, like on average. Is the way to think of that? Okay. So let's introduce this marginal product. It's directly related to the production function, but marginal product. So what does it mean? If every time Farmer Jack hires 1 more worker, his total production, the total number of products that he makes, goes up, right? Let me go back a graph. Every time that he hires 1 more guy, the total amount of products he makes goes up. 1 more guy, the total number of products that he makes goes up. 1 more guy, the total number of products that he makes goes up, right? Okay, so we're going to call that the marginal product of labor. So the marginal product is just how many more total products than the last time. Does that make sense? Okay. So in general, the marginal product of any input is the increase in output arising from an additional unit of that input holding everything else constant. Basically, I add 1 more unit of input. How many more products did I get? That's marginal product. It's very simple. Okay? And they call it marginal because margin, like, on your piece of paper, margin, the piece on the edge, it's like the last guy, the guy on the edge, the very last guy you hired, how much more did he bring to the party? Right? How much more product did he produce? We call that the marginal product. Okay? And so you probably have seen this before, the capital Greek letter delta. It means change in. Okay? So you are going to have a change in quantity. That's a change in total amount of product that's being made. Okay? Change in labor. That's the total number of guys that there are. Okay? And so marginal product of labor can be written mathematically like this. How much does the total products change when I change the workers by 1? Okay? That's what that means. How much does the total products change when I change the workers? That's what that's asking. Okay? So don't forget, or don't get confused, the difference between total product is the total number of Q that's being produced. The total number of Q. That would not be the delta Q. It would just be plain old Q. The marginal product is how much does the total product change when I add 1 more guy, when I change my labor. Okay? So here's the original production function from last slide. You guys remember that? Now, let's think this through. When I add one guy, what's his marginal product? 1,000. So I'm going to go ahead and write it right here, 1,000. Now, just so you know, in Applia, well, in this graph, you see I write the marginal product of labor in between. Why do I write it in between? Right, because it's in between 0 and 1 guy, right? Okay, so this marginal product of labor is always going to be kind of in between the two things, right? Hey, so going from guy 1 to guy 2, what's guy 2's marginal product? 800, right? So, whoops, too many clicks. 800. So his marginal product is 800. Meaning when I hire another guy, he brings me additional 800 products, right? In this case, it's wheat. So his marginal product is 800. Okay, this guy, what's his marginal product? 600. What's this guy's marginal product? 400. What's this guy's marginal product? 200. Okay? So if I were to ask you a question on test, I would say, what's the marginal product of worker number 3? That's like, how much does guy number 3 bring to the party? Well, you just look at 600. Okay? Some people, sometimes when I ask what's the marginal product of guy number 3, they're not sure whether to tell me 600 or 400. Okay? Don't make that mistake. Just realize, when I'm asking you what's the marginal product of guy number 3, it's like, how much does guy number 3 bring to the party? How many more products do we get that we didn't have from before? And it's clearly 600. Okay. All right, so that's the marginal product of labor. What do you notice about the marginal product of labor? It's decreasing, right? Okay. So let's go ahead and graph the production function again, and this time keep track of the marginal product of labor. Okay, so the marginal product of labor equals the slope of the production function. Oh, actually, we're not going to graph it. We're just going to realize that. I'm going to draw it out, actually, so to help you guys realize it. Remember the production function? Whoops, this was labor. This was quantity. Production function. Okay, important thing to know before actually I do this. Look at the axes of the production function. That's not in P and Q, okay? This is the first time we're going to look at something that's not in price and quantity. That's because this is not a market, okay? So Q, very confusingly, is on the y-axis, right? This is still the regular Q, like how much like they're making, the factory's making. But here goes on the y-axis, and on the x-axis goes labor, how much input, right? You could change this to another input, like the number of acres of land or the amount of seeds or something like that. But in this class, we're just pretty much going to stick with labor, okay, as the only input. Okay, so you notice that at one laborer, we had like what? Like 1,000, right? Oops, 1,000. And we had 2 laborers, and we had 1,800, right? So the marginal product of labor between guy 1 and guy 2 was 800. It's also the slope from here to here of the production function. Does that make sense? It's the slope of the production function. What do you notice about the slope from there to there versus the slope from there to there? Is it the same slope? This is smaller, right? Don't forget, as the curve gets closer to flat, that's 0 slope, right? This is a really big number. This is 0, okay? So the number's big here. The number's small here, okay? The number's big here. The number's small here, okay? So as the amount of labor increases, the slope, the MPL, the marginal product of labor, decreases, okay? That means as you keep adding additional guys, they bring less to the party. Does that make sense? They bring less to the party, okay? And so that's why the production function gets flatter. It kind of has this curved shape. Does that make sense to everybody? Okay. And so, yeah, here you go. Here's the slope from here to here, the slope from there to there. The slope's getting closer to 0 as the number of workers is increasing, because each additional guy that's showing up and being hired is bringing less total increase in total product. Okay. There's 1,000, then we got 800, then 600, then 400, than 200. And as you can see, the slope here at 200 is very, very flat. Okay, so why is marginal product of labor important? Well, it answers a very important question. Remember, everybody thinks of the margin, including Farmer Jack, right? Meaning, at the margin, should I produce one more bushel of wheat? That's what Farmer Jack's thinking, right? Should I produce one more bushel of wheat? That's at the margin, it's at the edge. Okay, so when he hires the extra worker, his costs rise by the wage he pays the worker, right? So he's asking, the original question he's asking is, should I make one more thing of wheat? But in order to make more wheat, I have to hire another worker. So now he's going to think about the worker, okay? When I hire one more worker, my costs go up by the wage, whatever the wage is, right? When I hire another worker, though, the other thing happens, I get more product to sell, right? So my revenues increase. Well, first he gets more wheat. And how much wheat does he get? He gets MPL, more wheat, more marginal product. And then that makes his revenue increase by the value of that. And so he can compare whether the worker's worth it, right? He compares the wage that he has to pay the worker to the marginal product of the worker. And then he's like, well, is it worth it? If the worker has zero marginal product of labor, he shouldn't be hired, right? But if the worker is very high marginal product of labor, then if it's more than the wage you have to pay him, well, then you should go ahead and hire him. Right? Okay. Why does marginal product of labor go down? Right? It's steep here. The first and the second guys have really big marginal product of labor. It means they're bringing a lot to the party. Now it's almost close to zero. Are guys number 4 and 5 more worthless than 1 and 2? No, actually. Whoops. The idea here is that how many acres total does he have? 5 acres. Yeah. In the example, he has 5 acres, right? It's not that they're less worthwhile, right? But when you hire more people, it starts getting crowded. It makes each person have a smaller and smaller amount that they can farm on, right? So they're clearly going to be less productive, okay? So every additional person he gets, his output rises by a smaller and smaller amount. Now why? Here's this. It's right here. This is the key. The workers, we're going to assume, just for the simplicity of this model, we're going to assume the workers are all exactly identical. It's not that some guys are better workers than others. We're going to assume that it's this. The average worker has less land to work with, right? Each guy has less land to work with when you add them on, so they get less productive. In general, marginal product of labor diminishes the more MPL you get, or the more labor you get, because there's a fixed input, okay? As long as you have one input that's fixed, you're going to get this production function that has diminishing marginal product of labor. Okay? In this example, what's Farmer Jack's fixed input? Land, exactly. He only has 5 acres of land, right? Now, if on the other hand, if he was buying more land and buying more workers at the same time, would his production function do this? No, it would keep being straight and go up straight. Does that make sense? The problem is that there's a fixed input. And in most companies in real life, this is true, right? There's only a fixed number of machines that they can use, or a fixed number of computers, or a fixed amount of factory space that they can use, right? There's always a fixed input, generally. And so that is the reason for the curve on the production function, okay? We call that diminishing marginal product. Diminishing marginal product. So the marginal product of labor is a big number here. As you get more and more L, the marginal product of labor goes to be a small number, starts to be close to 0. It's diminishing. You see that? Diminishing. Okay. It's important to note for diminishing marginal product that what we're talking about is the slope, or for those of you who have calculus, this is also the derivative of this curve, right? The slope or the derivative is going to 0. That's what's diminishing. But notice, it's always still going up, right? At no point in time is this thing actually starting to go down, right? So total product, get this, total product, or total production, is always going up. Total product is always going to be a bigger number. But the slope, the marginal product, is what's going down. Okay? Sometimes students hear diminishing marginal product, and they think it's like this. As you hire more and more laborers, first they make more products, and then as you hire more laborers, they actually start making less stuff altogether. That's kind of confusing and probably not likely, right? If you hire more workers, you're going to make, say I own a donut shop. If I keep hiring more and more workers, they're going to start making less donuts altogether? No. Each individual guy will make less work, will make fewer donuts, right? But overall, we're still going to have more donuts. We're not going to have the total product start to be negative, but the marginal product can be going to 0. Okay, so let's think about his costs now. So let's say that he has to pay $1,000 per month for his land, right? He always has to pay. Whether he grows 1 thing of wheat or 1,000 things of wheat, he still has to pay $1,000 a month just to rent his land, okay? Hey, what happens if he owns this land? Do I still have to think about the $1,000? If he owns it? Yes, because even if he owns the land, I still have to think of the $1,000 as a cost, because I could rent out that land to someone else and get $1,000, right? So I don't care whether he owns it or whether he rents this land, $1,000 is still a cost. Either he has to actually pay it, explicit cost, to somebody, $1,000, or he has to give up the ability to rent that. Either way you look at it, it's still $1,000 of cost. Now, let's say that every time he goes out and hires a worker, it's $2,000 per month. So he only pays for the number of workers he hires, right? So if he has 2 workers, he pays $4,000. If he has 10 workers, he's going to pay $20,000, okay? So this he cannot adjust. This is $1,000 that he can't adjust. He just has to pay it all the time. This amount of money he can't adjust. Well, the total amount for the workers he can adjust. It's just $2,000 per worker. Okay? So his costs are related to how much wheat he produces, because the more wheat you have, the more workers you have, then the more that people you have to pay $2,000. So let's put out the costs here. So here's the original production function. Yes? In all of these situations, whether he has 0, 1, 2, 3, 4, 5 workers, how much does the land cost him? 1,000. So the land always costs him 1,000 no matter how many workers he has. Okay? But what does change? The cost of the laborers, right? The cost of laborers. So if he has 0 laborers, how much does his labor cost? This is easy. If he doesn't hire anyone, yeah, 0, right? There we go. But if he hires 1 person, how much is he going to pay him? $2,000, right? He has to pay $2,000 per person. So you just look, you just take the number of people times 2,000, and that's how you get these numbers here. Okay? And then finally, the total cost. Well, he only has 2 inputs that he's paying for. He's got the cost of the land and the cost of the labor. Okay? So his total cost here is 1,000, 3,000, 5,000, 7,000, 9,000, 11,000. The interesting thing to note, even when he's making nothing, he still has a cost. Yeah, even when he's making nothing, he still has a cost. Okay. All right, so everybody understand how we made this table real quick? Okay. Let's think about the total cost curve. So I'm just taking the Q column and the total cost column from that previous slide. Okay, I threw away all the other columns, just the Q column. So basically, here's how his costs go up as his production goes up. Okay? And if I graph that, it looks like this. At 0, strangely enough, I still have a cost. How do I still have a cost if it's at 0? I'm not making anything. Why do I still have a cost? The land, right? Yeah, the rent or whatever it is, the implicit rent on the land. And then as I make more wheat, what do you notice about my cost? Not only does it go goes up at a steeper rate each time, right? So we could think of like the derivative is actually increasing. It's more positive each time I look at it, the slope is. Okay? All right. So this tells you that if I just kept trying to make more and more wheat, eventually my costs are just going to get completely out of control, right? It's kind of like self-limiting. I can only make so much wheat on this 5 acres of land, because if I try to make more, my cost is going to start getting way out of control. Okay? Now that we've thought about total costs, let's think about this concept that I'm going to introduce called marginal cost. Okay, marginal cost. The most important cost in this class, right here, right now, marginal cost. What does it mean? It's just how much the total cost curve goes up when I make one more unit of Q. Okay? It's just how much the total cost curve goes up when I make one more unit of Q. So that's it. Change in total cost over the change in quantity. So if I make one more unit of wheat, how much does my total cost go up? That's my marginal cost. Okay? Once again, the most important cost in this class. We'll use it in every chapter from here on out. Okay, so let's calculate that, right? Let's go ahead and pull up the costs, right? So I've got my Q and I've got my total cost. Now I want to know what my marginal cost is, okay? So as I go from 0 to 1,000 bushels of wheat, the cost goes from 1,000 to 3,000. That makes sense? So I have 1,000 more product. My costs go up $2,000, right? I have 1,000 more product. My costs go up $2,000. So what's my marginal cost? How much did my total cost go up every time I had one more wheat? Just $2, right? At this spot, every time I have one more product, it's costing me $2, right? Because every time it goes up 1,000, it goes up $2. Okay, but now let's see what happens. As I go to the next row, how much more product do I have? Only 800 this time, right? But how much did it cost me? Still cost me $2,000, right? So what's my marginal cost here? 2,000 divided by 800 products, right? $2,000 divided by 800 products, it's $250 now. It's starting to get a little more expensive. Each individual, so when I'm at, I don't know, 1,000 bushels of wheat, if I want to make 1,001 bushels of wheat, it's going to cost me an extra $250. Does that make sense? And now if I'm up here at 1,800 to 2,400, that's 600 increase. My cost goes up to 1,000. So 2,000 divided by 600 is $3.33. So now if I'm at 1,800 bushels of wheat and I want to make 1,801 bushels of wheat, it's going to cost me $3.33. Okay? This is like the per bushel cost, the per unit cost. Okay, and then as I keep going up, this is going down to 400, and this is staying at 2,000, so the marginal cost is $5. And then finally, the 2,000 divided by 200 is $10. So what do you notice about the marginal cost? Is it staying the same? It's going up, right? So as I make more and more wheat, the additional cost from one more wheat is getting more expensive, okay? And that's the idea behind this marginal idea, the marginal cost. If I'm making 100 and I want to make 101 products, how much does my costs increase? I'm talking about all of my costs, my total costs, right? So it kind of gives you an idea of like, how much did that last unit cost you to make, right? How much did this last unit of wheat cost you to make, right? Going from 0 to 1 bushel of wheat is really cheap. It only cost me $2, right? But going from 2,800 to 2,801, it cost me $10 to make the bushel of wheat. Okay? So it gets much more expensive. All right. So we can graph that. I just move these all together. These are the same things that we just calculated. As my quantity goes up, marginal cost generally goes up, just like we showed. Okay? So if I graph it, it looks like this. Right? As the quantity goes up, my marginal cost curve goes up. So this tells me at any one point, if I'm at 1,000 and I want to make one more, remember the marginal cost curve only tells you the cost of making one more because it's the marginal, it's the next step. And I just look at this and it's like, oh, $2, so or close to $2. At 1,000, it costs me about $2 to make one more. At like 2,000, it costs me $4 to make one more thing of wheat. That makes sense? we're almost done for today. Why is marginal cost important? Like I said, this is the most important cost in the whole class. Okay? Here's why. Farmer Jack is asking the question, I want to maximize my profit. Should I make more wheat? Right? So he's going to ask himself, should I sell one more product, one more bushel of wheat? So what's the thing he's going to ask? Well, how much is that extra cost? How much is it going to cost me to sell one more bushel of wheat, one more product? That's the marginal cost, right? He thinks he needs to think at the margin. What he's really actually implicitly thinking about is the marginal cost. Okay? So here's his decision. If his cost from selling one more thing of wheat, that's his marginal cost, right, is less than how much revenue he would get from selling it, well, he should definitely sell that next bushel of wheat, right? If he can go out and sell the wheat for $10 on the marketplace, but it only cost him $6 to make that wheat, that next wheat, well, he should absolutely make that wheat, right? And then he should not only make that wheat, but then he should ask himself again, should I make even one more after that? And he should keep doing it until he doesn't make any more money. Does that make sense? Then his profit is maximized. Okay. Okay. Let's define fixed and variable costs real quick. Fixed costs are costs that you always have to pay that they don't change depending on how much output you make. Fixed costs. They don't change. You always have to pay them no matter how much quantity, how much product you make. Okay. So what was Farmer Jack's fixed cost? His land. Right? He always has to pay $1,000. Okay. Other things in the real world that you might have as fixed costs might be, you have to buy a tractor. Might be cost of equipment. Maybe loan payments for your building that are the same all the time. Maybe rent for your factory that's the same all the time, right? Maybe you build a huge factory and so you have to pay, $1 million to build your factory. That's a fixed cost. It doesn't matter how much you produce. You're going to pay that same amount all the time. Now, there's also these things called variable costs. Variable costs change. They vary, hence the name variable. This is not variable like, oh, the variable x and the variable y. This is the variable like, oh, it changes or varies as time goes. Okay? And so these ones change. So some examples for Farmer Jack are, what's the cost of his that changes? How many people he buys, and therefore how much wages he pays to them. All right? Others examples are like the cost of inputs. If I own a donut shop, and I want to make more donuts, my rent on the building doesn't change. That's a fixed cost. The amount of sugar I buy, the amount of flour I buy, the amount of oil that I buy, those things do change with the number of donuts I make. So those are variable costs because they vary. And then the total cost that he pays, of course, is fixed costs plus variable costs. Total cost he pays is fixed costs plus variable costs. All right, so let's go ahead and move on to the next example. We're going to move away from Farmer Jack. We're going to move to maybe a more just general model, which is incorporates everything all at once. Okay? So let's say that our firm is going to produce either 0, 1, 2, 3, 4, 5, 6, or 7 units, and its fixed cost at every point in time is 100. So I don't know what this firm is. Maybe it's the taco shop. Maybe it's something else. But they pay $100 all the time. Maybe that's the rent on their building. Okay? No matter how much quantity they make, even if they make 0 stuff, they still have to pay the fixed cost. Okay? And so if I graph that, it's going to go ahead and be a flat line. Okay? These on here are going to be like the total cost, the cost for the production of the whole thing. Next, we'll look at like the marginal cost, or the cost of each individual unit. All of these costs are going to be like the total cost for the entire operation, because you kind of look at these are big numbers. It's going to be the cost for the whole operation. Okay, variable costs. So because it's a variable cost, if I make 0, I'm going to have to pay 0 for this variable cost, whatever it is. Maybe it's the tortillas or the carne asada or something like that, okay? And then it goes up, up and up and up like this. It also includes the wages, which is one of the primary reasons why you'll notice from 0 to 1 it only goes up 70, yeah? But from 6 to 7, what is that? It goes up 140. You see that? So the variable cost starts increasing faster. So when I graph it, it's going to kind of start taking off over here. The variable cost curve is going to start taking off. Okay? And then I have my total cost curve where I just add them both up. So in your brain, mathematically, you can think of adding up the numbers. Graphically, you can just look and you can say, oh, look, I need to add 0 plus 100, so the first point's here. And then for the total cost, I need to add, what is this, 70 plus 100. So the next point for the total cost curve is going to be like at 170, right? You just add them up vertically. Does that make sense? So you're going to get a curve. Well, first you'll add them up, and then you're going to add them up vertically like this, and you'll get a curve that looks like that. Okay? And so at every point in time, this green curve should be $100 above the orange curve. Right? Because we're just adding on $100 at every point. So the green curve should always be $100 above the orange curve because the green curve is the total cost curve that they have to pay. Notice it too experiences this thing where the costs start to get out of control. That's because, always because of diminishing marginal product, which means that if you put in more inputs, you don't always get a lot more output. You might just get a little bit more output, right? At the beginning, when you're adding workers into your factory, you might get big, huge jumps in your output. But then once your factory's full and you keep adding workers, it's just going to barely increase your output, right? And so in order to get to these high levels of output, you have to have lots of workers. And so that's really expensive. That's why the cost curves start to get out of control. Okay? Now, let's look at it in the marginal cost or the per unit cost, right? This was all in the total cost for the entire operation, okay? But now let's look at the per unit cost, the marginal cost. So I've got the total costs column and the quantity column. I've deleted all the other columns, okay? Because that's all I'm interested in for the marginal cost. So look at it. From 0 to 1, what's the change in cost? How much does it cost? $70 to produce that first unit, right? How much does it cost to produce the second unit? Only $50. And then how much does it cost to produce the third unit? Only $40. But then what do you notice about the costs? They start getting very high, right? This is a function you almost always see of marginal costs. So we take the change in total cost over the change in quantity, and almost always, so it might go down a little bit at the beginning, common, but almost always it starts getting sort of really high, out of control, right? And this is why firms can't produce an infinite number of quantities, right? This is why firms only produce a certain amount of quantity, because if they were to continue producing, the costs would get completely out of control. Does that make sense? And they would not be able to make any profit. All right. So yeah, like I said, sometimes, as in here, it falls a little bit before it rises. So, oh, and just a little important little thing. Sometimes we might show marginal cost to be constant, just to make the math easier on the problem that we're doing, right? But generally in real life, it's increasing. Okay, so when I graph it, it kind of looks like a swoosh, right? It goes down a little bit first, and then it goes up. And this is important to see the difference in this graph. You see these numbers are smaller than that previous graph, right? Because this is talking about the per unit costs. The other costs graph that I showed you a couple seconds ago on the previous slide was the total cost for the entire outfit, the entire factory. Okay? This is a per unit cost. That's why the numbers are smaller. And this is telling you, hey, in order to go from 2 to 3, that's that dot, it's going to cost me $40 to go from 2 to 3. Another important thing to notice, look, where are these things graphed? Are they graphed on the actual numbers? No, they're graphed in between. Just the same way these are written in between. Why are they written in between and graphed in between? Why? Because this point here tells you the change. If you're currently making 3 and you're going to go make 4, it's going to cost you this much, $50, right? And if you're currently making 5 and you're going to go make 6, you go to $100. It's going to cost you $100. So if you're currently making 5 and you want to make item number 6, right, taco number 6, it's going to cost you $100. Expensive tacos, but you get the point. So these are not graphed on the actual numbers, they're graphed in between to remind you that it's a marginal cost. It's the cost of starting here and making one more of whatever it is. Okay? So that's marginal cost. Here's another cost I want you to think about, average fixed cost. So all I do is I just take the total cost, the fixed cost, and divide it by how much I'm making, how many quantities I'm making. Okay? And so the reason why you do that is, let's say that you have a taco shop and you're paying rent and you're paying $100 a month on this rent, right? And let's say you sell some tacos. You want to be like, how much of the cost of each taco is going to rent versus going towards tortillas and carne asada? Does that make sense? So you're like, how much of this, of all my total cost of this one taco is going to paying rent? And that's the average fixed cost. Okay? So it's really quite easy. You just take the fixed cost divided by the quantity. 100 divided by 0 obviously can't be done, so there's nothing there. But 100 divided by 1 is 100. So if I make one taco, then how much of the rent is being paid for by this taco? All of it. All of $100 of the rent is being paid for by that one taco, right? If I make 5 tacos, each taco is paying $20 or so $20 to the rent. Does that make sense, what's going on here? So it's paying $20 to the fixed cost. And so as you produce more, what happens to the average fixed cost? It goes down. It always goes down. This one does not start going back up ever. Just because you have a fixed cost, this never changes, and then this number is always going up. So this divided by a number is always going up. It's going to mean this cost is always going to go down. Okay? So average fixed cost always falls as Q goes up because of that, the relationship right there. Basically, you're spreading your fixed cost out over more and more units of output. Right? So I have one fixed cost, rent, and I'm spreading it out on more and more units of output. So from a production standpoint, for fixed costs, I want to produce as many as possible, right? To spread this fixed cost out over as many products as possible. But that's not the only cost that there is, okay? Otherwise, if this was the only cost, you'd be like, just keep producing. The more you produce, the lower your costs are going to be, right? But this is not the only cost. Before I talk about the next cost, though, to graph it, it just looks like this, right? It goes down, okay? And it's always going down. Okay, but the next cost that we have to think about is the average variable cost. So this is the total amount of variable costs, right? So it's like the total amount of money I spend on tortillas and carne asada and labor, right? The total variable cost, right? The whole variable cost. I shouldn't say total because total is another thing. The whole variable cost divided by however many tacos you make or how much output you make, okay? And so this guy, as you can see, because the variable cost starts to get out of control. Remember we saw that the variable cost starts to get really, really high because of diminishing marginal product. Okay. When I divide it by Q, it might fall initially, but then it starts going up again. Okay. So we have variable cost. It may fall initially, but it's always going to start going back up. Okay. So unlike average total cost, which average total cost is always falling, average variable cost ends up picking up. And that's because variable cost starts getting out of control. So when I divide it by Q, it's still going to end up being big. And so it looks like this. You might have something that falls a little bit, but then it starts getting out of control. Once again, the reason why these costs get big on this side of the graph is because of diminishing marginal product. So as I use more and more workers or something like that, whatever input I'm using more and more of, they become less useful. That's diminishing marginal product, right? The workers become less useful. So in order to make these high quantities over here, I have to have lots of workers, which starts getting really expensive. That's why the price, or that's why the cost goes up for these guys. Okay? So that's average variable cost. If I were to add well, there's two ways to think about this. The next one's average total cost. So total cost is what? Just fixed cost plus variable cost is total cost, right? Fixed cost plus variable cost is total cost. So if I'm going to go average total cost, you could either go the total cost, which is fixed cost plus variable cost, right, and divide it by Q. You could do that, and so you'll get this. Just take the total cost and divide it by the quantity right here. Okay. The other thing that you can do is you can realize that total cost itself is just fixed and variable costs put together, right? So then average total cost is just average fixed cost plus average variable cost put together, right? You could calculate it either way. Okay, you calculate it either way. And to prove it to you, I've brought back our fixed costs and our variable costs from the previous slides, and you'll notice if you add these two guys together, it always comes up to the average total cost, right? So there's two ways to calculate average total cost. You can go ahead and just take the total cost and divide it by the quantity, right? Or you can just take the average fixed cost and the average variable costs and add them up, and you'll get the average total cost. Now, why is the average total cost important? Because this is another this answers another question. Like if I were to say, hey, you just made 10 tacos. On average, how much does it cost you to make each taco, right? That's your average total cost, okay? So you see the difference between that and marginal cost? Marginal cost is like, hey, I'm currently making 9 tacos. How much does it cost just to make the 10th taco, right? Very important for profit maximization, because then you can see if when you go sell that taco to the public, if you can, make more money than it cost you. But you might also need to know, hey, you're currently making 10 tacos. I'm not asking how much does it cost to make the next one. I'm saying on average, all of those tacos that you already made in the past, all 10 of them, on average, how much is it costing you to make all of them on average? That's average total cost, okay? So these are two incredibly important costs, and you've got to be able to keep them straight. Marginal cost, how much does it cost to make the next one? Average total cost. How much did it cost to make, on average, all of those tacos that you already made in the past? Okay? All right. So the ATC curve is usually U-shaped because it's ATC plus AVC. So because the AVC starts to go up in the end, the average variable cost, when I'm adding it onto the ATC, it's also going to make the ATC go up. So again, the cost goes up on this side of the graph because of the AVC, exactly. And the AVC, and in general, all costs go up on this side because diminishing marginal product. Okay, don't forget that. All right, so those are the costs. If I put them all on the curve together, you'll see ATC goes here, AVC goes here, which now you can see why the ATC starts curving up, because it's composed of the AVC and the ATC. So if you just add these two curves up, basically if you add the height of this plus the height of that, these two heights right here, you'll get this guy, right? And if you add the height of this plus the height of that, you'll get that guy. Okay. Something else to note if you want to draw these properly, which I think is extremely helpful when you're doing these problems, the ATC and the AVC start a little bit farther apart, but then they get a little closer. Right? When you graph the regular VC, variable cost, and the regular TC, total cost, they always stay the exact same distance apart, whatever the fixed cost is, right? But when you graph the average versions of them, which don't forget, these are the per unit costs. When you see the A's here, or the marginal, right? These are like the per unit costs. They're not the total cost for the entire factory. They're the per unit cost. It's getting skinnier and skinnier and skinnier. They get closer and closer together. Because the distance between these two guys is the average fixed cost. The distance between these two guys is the average fixed cost. And the average fixed cost is always getting closer to 0. So the distance between these guys is going to get closer to 0 also. Okay. So that's kind of what they look like together on a graph. There's one more curve, the marginal cost curve, which we'll put here. Okay, and that's what it would look like. I want you to note that the marginal cost curve always crosses the AVC and the ATC at the lowest point. See that? It crosses it. So if I want to say, where's the cheapest number of the number of tacos to produce, that it's the cheapest on average per taco, that's going to be the bottom of the ATC curve. So it's going to be wherever this intersects. Does that make sense? Okay. The marginal cost always crosses the AVC at the lowest point. Before we do that, I want to explain to you why it always crosses at the lowest point. Let me get another marker. Okay, let me draw in a marginal cost curve. And let me draw in an ATC curve. Okay? Brief review about what each one of these means. This is quantity, and this is dollars and costs. Right? If the marginal cost says, okay, if I make, one more unit, how much is it going to cost for that one more unit? The average total cost says, what is on average, how much did you spend on all of these per unit? How much did you spend? Okay? And so if you look at it, look, if you're down here, the marginal cost is really low, right? So that means if I make one more taco, it's pretty cheap to make that one taco, right? So what does that do to the total cost on average? It's bringing it down. Why? Because you're making cheap tacos. The marginal cost, to you, they cost very little, right? So it's going to bring the average total cost of each taco down. Does that make sense? But then over here, what's the marginal cost? Really high. That means if I make one more taco, then it's going to be really expensive, that next taco. So it's going to make, on average, all of the costs of my average taco go up. Does that make sense? Here's another way to think about it. What if you put time on this axis and GPA on that axis? Okay? What if you got this quarter a 1.0 GPA? That would be way down here. Right? And what if the next quarter you got another 1.0? Okay? What's that going to do to your overall average GPA? If I were to graph your overall average GPA, what's that going to be doing? Boo! Right? But then, what happens if you decide to get a 3.0 and then a 4.0? Right? And so your GPA over time is going up like this. What's that going to do to your average? Sometimes they call it cumulative, which is like average GPA. What's that going to do to your average GPA? It's going to bring it back up. Hey, look, this graph looks just like that graph. You see that? Where marginal cost is like, your GPA every single semester. And then average total cost is like your overall total cumulative average GPA. Does that make sense? So anytime the marginal cost is above ATC, it's pulling the ATC up. Every time marginal cost is below ATC, it's pulling ATC down. That's why mathematically it has to be true that the marginal cost crosses ATC at the minimum point. Okay? And in next chapter, it's going to be important to know where the bottom of the ATC curve is, because that's like where it's cheapest to produce, right? And so how can you possibly know that? Easy. Just look at the point where marginal cost crosses ATC. That'll tell you the minimum point. Okay? All right. So let's make sure that you're paying attention. Go ahead and fill in the blank spots on this table. So there's enough things filled in here. So you'll have to figure out variable cost, total cost, you're going to have to figure out in your brain what fixed cost is, and then you can find out average fixed cost, average variable cost, average total cost, and the marginal cost. All right, so as I was mentioning, the first kind of hint to look at is, even though I don't have a column for fixed cost, you need to realize that there is a fixed cost, because when I'm making nothing, I still have to pay, and so that must be my fixed cost, $50. So at every quantity, there's a $50 fixed cost. I can go ahead and fill out my average fixed cost entire column now just by going $50 divided by the quantity. Okay, so right there, fixed cost equals 50. And then once you, additionally, after you do this guy, you can also know that variable cost and total cost is going to equal 50. So you know that you can figure out most of these from the 50. From 50, right? You know this has to, these together, this plus 50 has to equal this guy, 60, right? And then the same thing here. This plus 50 has to equal 200, okay? Then you go average fixed cost divided by the quantity, and so you got these guys right here, right? Just 50 divided by 1, 50 divided by 2, 50 divided by 5. You got these guys right here, okay? Then average variable cost. Well, now you have almost all the variable costs, so you can do the average variable cost. It's just variable cost divided by Q. So you've got 10 divided by 1 is 10. You already have that one. 30 divided by 2 is equal to 15, right? And then 100 divided by 4 is equal to 25. Okay. Next, you can get marginal cost and total cost, right? So if the total cost went from 60 to 80, the marginal cost between these two guys is 20, right? From 60 to 80. And if the marginal cost is 30 here, that means it goes from 80 to something that's 30 higher. So it's 110. Okay. 110 to 150 then is $40. 150 to 200 is $50. Okay. And then this one's already done for you, 60. It's 200 to 260. Okay, so we're almost done. Finally, average total cost is total cost divided by quantity. So we've got total cost 80 divided by quantity 2. That's going to be 40 in there. Total cost 150 divided by 5, or excuse me, total cost 200 divided by 5, that's going to be 40 in there. Okay? So you can see that the ATC starts going down, but then it starts going back up again. Marginal cost is going up the whole time. Right? We always know as we get to the right side of that graph, as quantity increases, that all these per unit costs, all the averages and marginals, the per unit costs start getting high because of diminishing marginal product. All right. Questions on how we do that? All right. So why the ATC is usually U-shaped? This comes back to what we were talking about here. Initially, right? So ATC is adding up the average fixed cost and the average variable cost, the AFC and the AVC, right? So at first, the falling average fixed cost is pulling the ATC down, but then we know that AVC starts rising over here, and that's what pulls it up on this side. Okay, pulls ATC up. So the point that is at the bottom of the ATC curve is important. The point that's at the bottom of the ATC curve is important. Why? Well, we call it efficient scale. Why is it important? It means like how many, if I wanted to make tacos as cheap as possible in my taco shop, how many of them should I make so that per taco it's the cheapest possible? Does that make sense? Right? And at this point it would be 5. Okay? It's the point at which it is just most efficient for me to produce at. That's why I call it the efficient scale. So scale, have you guys heard this term used like this, like the scale, the scale of operations? Scale just means how much quantity you make. Okay? Right? Scale just means how much quantity you make, right? Oh, I want to scale up my business. What does that mean? I want to make more quantity. Okay? So the efficient scale just means the quantity or the amount that is the most efficient, in which it's cheapest for you to produce. Okay? So this is another very important part It's the bottom of the ATC. It's where it's cheapest on average for you to make your product. And how can we find where the bottom of the ATC is? I just look where the marginal cost crosses it. Okay? All right. So let's throw that marginal cost curve on there, and you see it'll cross at or very close to the bottom. Okay. When the marginal cost is under the ATC, right? When the marginal cost is less than the ATC, that's this point right here, right? That means that each additional taco I'm making is pretty cheap to make. So that's making, on average, how much I'm paying per taco go down. That's all I get to hear, right? ATC is falling. But on the other hand, when I'm at the spot where marginal cost is above ATC, marginal cost is above ATC, that's this right-hand side of the graph, okay? Again, marginal cost is super high up here because diminishing marginal product, it costs a lot to make these extra tacos because I have to use a lot more employees, right? The tacos over here are expensive per taco, and so it means on average it's making my average go up. Okay, the ATC is going up. Does that make sense? So the key here is that the marginal cost curve, the MC, crosses the ATC at the bottom point of the ATC. And the bottom point of the ATC, it's called the efficient scale point, right? It's the place where it's most efficient to make my product. So this is an important point, really important point. And the two most important costs. This is the number one most important cost, the number two most important cost. Okay. So now that we kind of have those ideas, let's transition a little bit to the short run versus the long run. Okay, I'm going to give you a formal definition of these terms. The short run just means kind of like in the near future, and the long run means in the long-term future, long time away. Okay? So in the short run, here's how we categorize the short run. This is the definition of the short run. Some of the inputs are fixed. We call them fixed costs, right? In the short run, I don't know, tomorrow, I can't change the number of factories I have, right? I can't change my rent. So that's all fixed costs, right? It doesn't change. The only thing I can change tomorrow is how many tacos I make. That's a variable cost, right? Or how many people I hire for the day, right? Okay. In the long run, however, all inputs are variable. So in the super long future, right, a couple years from now, I can change the number of factories I have. I can change the number of taco shops I own, right? I can buy more or I can sell them. This process takes a long time, right? So tomorrow, the only thing I can change, the number of tacos I make, the number of people I hire. But in the super long run, I can change whether I have 2 taco shops, 3 taco shops, 0 taco shops, right? I can change my fixed costs. So in the long run, there's no such thing as a fixed cost because everything just gets changed into a variable cost in the long run. Okay? In the long run, all the inputs are variable. So if I were to ask you, okay, today is today, how long till the short run turns into the long run, right? That's a really good question. Just how far out there is the dividing line between short run and long run? Well, it's the amount of time it takes to take all of your fixed costs and sell them or buy more and change them into variable costs, right? So let's say that I have my taco shop and my lease is for a year on the taco shop. I can't change anything for that 1 year, right? But after that year's over, I can decide to not renew my lease, or I could get three or 4 taco shops, right? I could change the number of taco shops I own. So the dividing line between the short and the long run would be like 1 year, however long it takes to change your fixed cost into a variable cost. Okay? And so in the long run, the ATC, this is important, the ATC at the long run is a little bit different because I don't just have to change the number of workers I have. I can also change the number of factories I have. And remember why ATC goes up on the right-hand side? It's because of diminishing marginal product. If I put more workers in my factory, they get really crowded, right? And so it starts going up. Well, if I can just build more factories, I don't have that problem anymore. So the ATC takes a much longer time before it goes up. It stays flat for a very long time. Okay? That's because we can change the amount of factories and the number of taco shops we own. Let me show you a picture. Okay. So here's the average total cost on this side. Here's Q on this side, right? So I'm going to put a per unit cost here. All right. Let's imagine that in the long run, you can change the size of your factory. Normally, the factory is a fixed cost, right? But in the long run, you can change. You can have a small, medium, big factory. Maybe this just means like 1 factory, 2 factories, 3 factories, something like that, right? And so each factory has its short-run average total cost curve, right? So if I just have 1 factory, remember the average total cost curve goes down and up. Right? But then if I have a medium-sized factory, or maybe I have 2 factories, the average total cost curve for this guy is going to be down and up here. The average total cost curve for the large factory is going to be down and up here. Okay? At any individual point in the short run, I can't change the size of my factory. Either I'm stuck on the ATC for the small factory, I'm stuck on the ATC for the medium-sized factory, or I'm stuck on the ATC for the large factory. In the short run, I'm only stuck with the size factory that I have. Okay? And then if I want to change quantity, I just change the number of workers and stuff. But in the long run, I can jump between these curves. Does everybody understand that? I can jump. I can switch whatever size factory I want in the long run. So the long run ATC curve is going to look like this. Oh, well, let's see how we get there. Okay, so if I want to make somewhere between 0 and QA, it's cheapest to be on the ATCS, right? So I'm gonna have a small factory. Okay. So if I want to make between QA and QB, it's cheapest, this is lowest, it's cheapest to have the medium-sized factory. If I want to make between QB and higher, it's cheaper to have a large factory. Okay. So if I'm asking like, what's my long-run average total cost curve? It's going to be the minimum point of all of these right here. You see that? It's going to be the minimum point of all of those because I'm not just stuck on one curve. So in the long run, since I can choose what factory size I have, my long-run average total cost curve, it's flatter. It's flatter. And again, the intuition, why is it flatter? Because remember the reason all of our cost curves go up on the right-hand side of the graph like this is because of diminishing marginal product. If I only have 1 factory, I put more workers in, they get crowded, they can't produce as much, costs start skyrocketing, and it goes up like that, right? Well, if I could just, instead of costs skyrocketing, because all my workers are crammed in there, what should I do? I should just build a bigger factory. I can do that in the long run. I can't do that in the short run. That's because it takes like a year to build a factory, right? So I can do that in a year. And then no longer do I have these crazy costs getting out of control here because all my workers are smashed into 1 factory. Rather, I have a bigger factory, so my costs fall, right? But if I want to make even more quantity and I shove even more workers in there, they start stepping on each other's toes, diminishing marginal product. It starts getting really expensive again. That's a bummer right now. But what should I do? In the long run, I can just build a bigger factory, right? And so I do that and my costs fall again. Okay? So that's why the long run cost is super flat. Where the short run costs are more like curvy U, I'm saying this right? The short run costs are more curvy. The long run costs are more flat. So if I have, just in general, for a long run average total cost curve, let's say there's, I don't know, 1 million different factory sizes instead of just 3, right? I was kind of making it simple with just 3 factory sizes. Let's say there's a ton of factory sizes. Then what's the long run average total cost curve look like? Just the minimum point of all of these guys. Can you see that? So the short run average total cost curves are right here. All of these little ones, and they're really steep. In the long run, though, I can just build any size factory I want, and I can minimize my costs better. So it's going to be much flatter. OK, so let's talk about ATC and the scale of production. So what does scale mean? Who remembers? I want to scale up my business because I want to make more quantity, right? So as I change the amount of quantity, that's all that scale of production is meaning, right? As I change the quantity, how does average total cost change? Well, if my long-run average total cost curve looks like that, then what do you notice? As I produce more, my average total cost curve is doing what? Falling, right? So it's getting cheaper and cheaper per unit, or per taco, per whatever that I'm making. We call that economies of scale. Economies of scale. So as my scale increases, as Q increases, it gets more economical. That's what this means. Economies of scale. Right? And so I probably should make more. I probably shouldn't make this much. I should make more because it gets cheaper for me. Okay? The costs go down. Now, when I'm at the flat point, constant returns to scale. Constant returns to scale. So, as I change my scale, my costs stay constant. And then what do you notice about this guy way over here? As if I keep making quantity, what happens? My total costs eventually go up, right? And I call this diseconomies of scale. This is the opposite of economies of scale, right? Diseconomies of scale. And it's a helpful side hint. You might be like saying, hey, why is the average total cost curve going up? Because I thought that it only goes up because of diminishing marginal product. And if I can just keep building bigger and bigger factories, then I shouldn't have people stepping on each other's toes, and my cost should never go up. That's sort of true, except for you got to remember, there's like one manager. And as he gets a bigger and bigger factory, he can't manage quite as well. You know what I mean? So stuff starts falling apart. Because there's only one guy, and he's only you know what I mean? He's only managing. So you can think about the only one owner as like the fixed cost that you can't change. You can't clone yourself and duplicate yourself, right? So that can never actually be changed. But you can think of like the fixed input as the owner, and that's why the average total cost curve goes up in the long run also. Okay. All right. So why does this happen? Economies of scale. Why does the dropping part happen? Well, because if you start making more and more and more, your workers start specializing, right? Instead of one guy having to press the tortillas and cut the carne asada and make salsa, right? If you can just hire 3 guys, and one guy can do tortillas, one guy can do carne asada, and the other guy can do salsa, and then it's now cheaper because guess what? The salsa guy gets really good at making salsa, right? He's quicker and faster. And the carne asada chopping guy gets way better at it, okay? So when you have low quantity and you hire a couple more guys, they can all specialize and your costs fall. Now, the diseconomies of scale, this is what I was telling you. Why does it end up going up? Well, because there's only one manager or one owner. We're going to call this coordination problems, right? Your management becomes stretched or stressed out, and they can't manage as effectively. So it can get too big. Even if you can still keep building factories that are bigger and bigger and bigger, at some point it gets too big for the manager to oversee all of it. And then people, I don't know, they start slacking, or they don't work as hard, and then their costs go up. Or they become wasteful. And of course, that happens when Q is high. Okay, so costs. Very important. It also happens to be very important for 14, 15, 16, and 17. So you'll have to know this chapter for the next 4 chapters we're going to do. And we have the various cost concepts. We have total cost, variable cost, fixed cost, and we have all the average versions of them. Average variable cost, average total cost, average fixed cost, and the most important cost, marginal cost. Okay? And then in the next chapters, 14, 15, 16, 17, we're going to use them, and we're going to talk about profit maximization in different factories. Okay?